Hello everybody, welcome to the second half of chapter 2.6. This video is going to be short, sweet, to the point. We're just talking about inverse trig functions and their derivatives, or inverse trig derivative functions, I guess is the correct way to say that. And what we're going to be doing in this video is we're going to be learning and applying inverse trigonometric derivative functions. So let's just jump right in. You should know the following things. First of all, the AP exam focuses on inverse sine and inverse tangent derivatives. So you should know those. It's not the only thing the exam focuses on, that's not what I'm trying to say, but as far as inverse trig derivatives go, sine and tangent are important for you to know. So of the 6 I'm going to write down, please focus on sine and, or I should say arc sine and arc tangent. Those are going to be important for you to know. So, the derivative of arc sine, or sine to the -1, of u. And remember what we talked about before with this u piece is more than just x. This is another function, something going on that's more than just an x by itself. And we can take that derivative by doing u prime over the square root of 1 minus u squared. The derivative of the inverse of tangent, of arctan, again, of something more involved than just x, would be the u, whatever's going on, u prime, over 1 plus the u squared. Derivative of the inverse of secant would be u prime over absolute value u radical u squared minus 1. Derivative of inverse of cosine is negative u prime over radical 1 minus u squared. Notice that the original rules for the derivative of cosine, derivative of sine hold here, where we have the opposite thing for cosine. Opposite sine. So if you have the derivative of the inverse of cotangent, then we have negative u prime over 1 plus u squared. Again, notice the similarities between arctangent and arccotangent. And lastly, derivative of the inverse of cosecant is negative u prime all over absolute value u over square root of u squared minus 1. Again, notice the similarities between the inverse of secant and the inverse of cosecant. We have almost exactly the same thing, except for cosecant is negative, and that happens here with cotangent and cosine between sine and tangent. So we have these relationships clearly going on. Make it a little bit easier for you to remember. Let's do some examples of applying these. So if I wanted to take the derivative of the inverse of sine of 2x, and notice this is a u case because there's more than just x going on, we have 2x. I'm going to use my rule to help me with this. I'm going to take u prime, derivative of 2x, which is going to just be 2. And then I'm going to say over the square root of 1 minus 2x squared, which is going to be 2 over the square root of 1 minus 4x squared, and I will be done. And again, I want to point out here that my u was 2x. And I'll do a little box over that guy in a different color. There we go. Alright. Next example, let's talk about the derivative of the inverse of tangent of 3x. And before we get started, again, let's identify that u, so this process is that much easier. We'll say that u is this 3x. Do a little box around that. And now let's apply the arctangent derivative. So we're going to have u prime, which in this case would be 3, all over 1 plus u squared, 1 plus 3x squared, which is 3 over 1 plus 9x squared, and that's all we can do. We're done. Last example, and then I'll leave you guys alone. Make it a short video today. The derivative of the inverse of secant of e to the 2x. And it's important that we understand the u in this case is e to the 2x. And so what I can do is I can look up at secant's inverse of secant's derivative, and I have to take u prime, so I have to take the derivative of e to the 2x, and what I can do there is I can apply the chain rule. I can see that my derivative is going to be 2e to the 2x all over, and let me quickly explain why this is 2e to the 2x, because that wasn't all that intuitive to me personally, and I'll just I'll do a little arrow over here so you guys can see why this is true. When we take d dx of e to the 2x, the first thing that's important to do here is to rewrite this as e to the x squared. And from here, we can do the chain rule, so we can put, let's do this down here, we can put the 2 out front, and then we still have the e to the x inside, and then this becomes to the first power. And then we take the derivative of the inside, and the derivative of e to the x is just e to the x. So this is what we're left with. And then what we have is e to the x times e to the x, which would be e to the x squared, or e to the 2x. And that is how we got this as our derivative, our u prime. Okay. And then let's follow the rest of the inverse of secant's derivative rules. If we look at the bottom here, we still need to do the absolute value of u, and the absolute value of e to the 2x is e to the 2x, so that doesn't change anything. And then we say times the square root of e to the x squared, e to the 2x squared, pardon me, minus 1. And when we simplify that, we get 2e to the 2x all over e to the 2x outside radical e to the 4x minus 1. And what we can do from here is cross off these e to the x's that are the same top and bottom. And so our answer is 2 over square root of e to the 4x minus 1. And that would be our answer. Alright, thanks for watching. We'll see you in class tomorrow.